Good evening, everyone. Thanks for inviting me. Thanks for this lovely area to do this. And I'm going to talk about how to create havoc in cloud and Kubernetes. Also highlight how we can solve it. And I think the next two talks will probably focus mostly on how to solve things. I want to make something very clear. There are stuff in the presentation which at first glance might look offensive. I'm not bashing on any vendor. I have examples for any vendor, any cloud. So the information is pure informational. There's no bad underlying idea. But I just want to point out what the security risks is and how to solve them. All right. So I'm Philippe. I'm a cloud consultant at Fortinet. I cover basically EMEA, but I have these red people here, and one in a white shirt running around. They're basically based in Switzerland. I also host, already for more than 16 years, a hacking conference in Belgium. Maybe you heard of it, Brucon. It's pretty known, although I say it myself. And in all the free time I have left, I typically do some logging, researching, which is mostly hacking-related stuff in cloud and Kubernetes. I love Kubernetes, I love cloud, but I also like to break it, which is my second passion, which is basically training and pen testing. So, slides, links, and whatever. I'm not going to show you every link I open or mention. If you scan that QR code, you can find the slides and the links, which I typically discuss, and from previous events. So, slides will be shared, no worries. So let me start with some high-level slides. And because we're talking Kubernetes, we're talking cloud, but at the end of the day, what do you want to do? Run applications, run code, all right? And I was involved like 16 years ago already, I think, with OWASP. So I saw the entire evolution. Yes, I'm old, I know. But at the end of the day, we need to always step back, and I always see that we need to step back and take a look at what we want to do. So building code is one thing, and I admire all the developers that do that. But then you have the security guys that sit underneath and says, this is wrong, this is wrong, this is wrong. And in the 16 years, I've never seen it working. I mean, there's always these guys against these guys, and then you have pen testers that make life difficult. And this game has been going on for as long as I'm in IT. And today, all this thing seems like solved because we have DevSecOps. And there's a little bit my problem. We try to merge these two together. We try to build code. We try to secure the code. And on top, it needs to be fast. It needs quick. And then people say the tools we used before don't work in a DevSecOps mentality, so we use new tools, but they forgot to look towards the past. And that's a big problem, although I find. So keep that in mind. At the end of the day, we're building stuff, and we want to run it securely. So you probably have seen these kind of slides like 10,000 times, but I want to stress one thing. When you're trying to build code, whether this is a Node.js app, a Python script, a Terraform plan, I don't know what, an Ansible script, this is code. That code is written somewhere by the best and okayest developer in the world. And just imagine he's a perfect developer. He's still writing that code on his desktop. Or perhaps in a container in Google, or perhaps in a VM somewhere on a ESXi host. That's the first angle where there's a lot of impact. If you can target the developer workstation or the IDE, it's a great source to create havoc. And don't think it doesn't happen. Just search Google for example, visual code exploits. You'll find them, yeah? So this is the first angle, which is typically overlooked, and why I'm pretty conservative. If you do this on secured workstations or in secured environments. Don't just copy-paste something, do it in your home desktop, and then copy it back. Yeah? So we can train our developers. We can secure where we write all this code. And then it just gets worse. We need to share the code. We're going to share the code in a code versioning system, whether this is GitLab or this is GitHub or whatever you use. It's a code versioning system, meaning that it stores code and the history of all the changes. There was a recent article published somewhere where they looked through GitHub repositories and they tried to find AWS access keys. The results were frightening. I mean, it's not because in your GitHub repo on the master branch you don't see any AWS access keys. If you put them on your desktop, you commit, you delete them, and you commit, and you push, they're in GitHub. Yeah? So secrets leak through everywhere, whether it's through GitHub, whether it's through container image. Same for a container image, by the way. If you add something and you delete something, it's still in the image layer. Yeah? So there are a lot of angles where an attacker can just go and try to focus you on your desktop or just go through your repo to find things, to hack into your cloud, create some malicious code, whatever. Yeah? And then we found a solution. When we push something to these code versioning systems, there is something like a webhook that will trigger your CI/CD system, whether this is Tekton, whether this is GitLab, whether this is, I don't know what, GitHub Actions. And automatically everything gets tested, published, and if you're fearless, pushed to production, whether this is to Kubernetes, or whether this is to an EC2 instance, or whether this is to, I don't know what, a Lambda function. Yeah, it's not because there's a Kubernetes logo. And meanwhile, we store the stuff in registries. So all these components, they run somewhere. Yeah? Whether it is in public cloud, on the internet, in the data center, software as a service, yeah? Or on an edge device, we've seen questions coming like, can we run it on a AWS Snowball device? Don't ask me why, but we get these kind of questions. Just think that this is just what the developer wants to do as best as, but all that stuff needs to run somewhere. So reach out to these red guys here. Yeah? They have solutions to secure public cloud, to secure on-premise data centers, to scan for vulnerabilities, whatever you like, all right? So there are a lot of solutions out there to secure it, yeah? I think the main takeaway is solutions exist, but we need to adapt and know what these solutions do, yeah? If you want to make things a little bit more complex, you can also introduce GitOps, which I find a cool concept, and it just automates even more. Now, just assume that whatever I showed here on these slides is technically okay without any vulnerabilities, all right? This works, and this is not vulnerable. I don't have to come up with examples, you all know them. Everything which was on the slides has found vulnerable. Yeah, just think about Log4j. I was probably the first one getting an email from AWS saying that my GitLab server was vulnerable to Log4j. Yeah? So keeping these components secure is already an immense task. I mean, the infrastructure that hosts it, or whatever it sits, needs to be secured. Yeah? A Kubernetes cluster without a firewall is a pretty dangerous thing, believe me. All right? So just assume that all the stuff is working fine. Now, I took the liberty to steal this slide from Gartner, and it kind of captures what the risks is and where to look at if you want to protect cloud-native apps. And I'm not going to read all this stuff, but you can see that the slide is basically cut in two. This is what you would basically consider as shift left, while you're building code. Yeah? The right part here is targeting what if that code is running in production. Yeah? These are two distinct, different phases. We try to push very hard to say shift left, shift left, shift left, shift left, because it suits well containers. But it doesn't mean that you don't have to protect what is actually running. Yeah? And as you can see, there are a lot of things you can do. Yeah? So I did a similar presentation, like I think 2 months ago, and I said, I'm not going to steal quotes or links, just going to take the proof in the pudding. Yeah? And I started scanning the latest images. So this was 2 months ago, the latest Python image, with 16 critical vulnerabilities in it. I took the latest Nginx one, 3. Node.js, always funny, yeah. That means that if you take the base Node.js image, that you're already stuck with these images. And quite often, they're unpatched, or even not patchable. Yeah? So that means that if it can be exploited through some means, an attacker has quite some options, if it can gain access to the app, to basically try to break out of things. So somebody told me, yeah, you have to use distroless images way better because there's nothing in a distroless image. So if you scan it, you see it's very low. There are only 2 binaries in, but if you follow this link, you'll see how you can exploit it through OpenSSL, which is a security tool on it. It's a very good document. The link is in the notes. Take a look at it, because it actually shows you how to install a backdoor through OpenSSL. It's pretty intriguing. So I was invited a couple months ago to join a talk, a very good talk about Tekton. I don't know if you know Tekton. It's a kind of CI/CD system that runs in Kubernetes. A very cool thing. I love it, really. And the cool thing is you can build your own tasks and pipelines and all that kind of stuff. But there is an option to actually use Tekton Hub, which is actually a shared hub where you can pull down all these tasks. So I was kind of wondering, like, in a CI/CD system, it has access to basically everything, to basically every secret, pulling down something from the internet. And I was actually filing through the files until I actually found what pods and containers were actually being used to do the tasks. I love Tekton, but don't use Tekton Hub. Yeah? It's good to have ideas, but don't use it in production. I didn't mention it here, but there was one with 2,600 vulnerabilities. So, and you see these are things which are used not only there, but basically in quite a lot of other places. So think about, it's not your code, yeah, only, but also your CI/CD. And if there is one place I want to attack, it's your CI/CD pipeline, yeah, because it has access to basically everything. So I said, okay, I give up. I'm going to write my own containers. So you can use mine if you want. This is the latest one from Ubuntu, 12 low vulnerabilities. This is the same Ubuntu infected with a backdoor, which is more than 7 years old, and it also has 12 low vulnerabilities. So it's very easy to create something that basically escapes all these scanners. Whether it is open source or enterprise, you can escape that. Why? Because these scanners work in a certain fashion. If you do something abnormal, none of these scanners actually find these issues. So don't use that, because I still have downloads on that part. So, but this actually, if you run it in your CI/CD pipeline, if you run it in your, on Docker for Mac, if you run it on your Kubernetes cluster, actually creates a reverse shell so that I can actually have access to your system. So it's really not difficult. Yeah. I tried this on a new service which was launched a while ago, and it works. Why? Because that container app is running on the internet without anything in front of it. I tried this right after, and it works. I have a backdoor running on Azure apps. And this works on AWS, this works on Google, this works on anything. It's not, I needed to have one demo, all right? So protect these things and create visibility, because that's the hardest thing to do. So I said, okay, my backdoor is not detected. How can I make sure that I'm not fooled by my own backdoor? And it wasn't as easy as I thought. I had to go and search for open source software like Yara Hunter that says, okay, there's a kind of backdoor, Tracy, but it means you have to run it in a sandbox, yeah, which is pretty hard to do. And yeah, believe it or not, I'm not wearing a red t-shirt, but I had to put a FortiGate with an IPS functionality in front of it to actually see my backdoor being stopped. Yeah. On top, very smart people released something which is called OCI artifacts, which is basically how you store images. They added a nice feature that you can actually store anything in a registry. And they basically make fun of it, say, don't store videos in Docker Hub. If you search it, you actually see it in the doc. So I said, cool, why is it used? To store SBOM, I don't know, whatever security-related information. So I thought, can I upload a virus into the Docker Hub? So I took the liberty to put a virus in it, in the public Docker Hub, and it's still there for more than 3-4 months. And nobody says something, nobody detects it. The only way I detected was because my firewall said, hey guys, you're actually downloading viruses from the internet. So be very careful with this, and you don't need a lot of expertise to download that stuff in a Kubernetes cluster. Just having access to curl is enough. Yeah? So that all being said, malware, backdoors, CVEs, it's all public know-how. But still, there is no single line of code at that moment. So we still have to write code. So I'm a very big fan of OWASP. And I thought in the beginning when I started analyzing Kubernetes, and I talk pure DevOps, I'm not hitting on that application security was like, that's another meetup somewhere. That's OWASP, that's not cloud. But at the end of the day, your code is running and is exposed on the internet. Yeah? If you write Node.js, your code is running. It's using libraries that it pulls from somewhere left or right, makes your code vulnerable. The chance of being hacked through a web application vulnerability is way higher than being hacked by a CVE. The problem is if you have access through a web app, you can exploit any CVE you want, basically. Yeah? That's your area where you actually have access. When you see the CVEs, they say you need network access. Fine, but you still need to get there. Yeah? But through a web application, it's very easy. This is something I copied earlier. If you would scan PyPy, I don't know how, you also find intriguingly high, strange, vulnerable numbers, yeah? Like AWS access keys, credential stealers, which are also scanned and never found, yeah? So please be very, very, very careful. And I know everybody's saying, but we don't pull anything from the internet. Apparently, the statistics say that more than 50% pull stuff from the internet and Docker Hub, so it happens. So a big plea here, please include security scanning as much as you want, yeah, whether it's open source or enterprise. Please include it the moment you write your code. use common sense. Yeah, use these tools. They're pretty cool tools that integrate with Visual Studio, like 3V or open source Sneak or whatever. It works pretty fine. It gives you a lot of ideas. It works on Python code, it works on Node.js code, it works on Terraform code, it works on Docker files. And the cool thing is, you can fix it before you push it to GitHub. Yeah? So take into account like 3V here in this case. It's very easy to use, and it gives you a lot of information. Once your applications are running, you need to test. Yeah? So you can actually opt for dynamic application security testing, so basically black box testing, scanning, doing whatever. Again, there is a whole wide area of tools, from commercial tools to open source tools. Now, why do I split these two up? I'm very fond of open source tools. Yeah, they do great stuff. Sometimes they're even better as enterprise stuff. But what's the difference? The difference is that if you want to secure this entire pipeline, you probably need how many tools? 20, 30, 40? They all spit out text logs, and you're sitting on a pile of text logs. Enterprise tools can take these logging information and create some actionable insights on it. Yeah, that's why it is very useful to do that. Now, we're talking about code. Let's go back to Kubernetes. You need YAML. Yeah, I love YAML. And again, in a Kubernetes manifest file, you can run a pod with 4 lines or 5 lines of YAML code, I think. If you want to totally secure it according to best practices, I think it's about 50 or 60 lines. So what are these 55 lines? So you have a lot of these best practices to say, okay, don't run as root, put a security profile, don't mount the file system as read-write, and so on and so forth. It's good advice if you can do it. But there is a cool tool that says if you don't use liveness probes or readiness probes, it basically says that your code is not okay. It gives you a higher risk factor. It's not best practices. So when I get annoyed, So I try to put backdoors in readiness probes and liveness probes. And my risk score went down. So it passed the CI/CD system. It was all green with a backdoor. And you don't have to be an expert to see that this is a backdoor. Yeah? So again here, these tools, be very careful. They look for best practices. They don't check for hard-coded backdoors. And to be fairly honest, ChatGPT could find it, so I guess these scanners could find it also. So be very careful if you push these things. We talked about CVs and stuff like that, but scan these images. Look for secrets, scan for secrets, check for viruses and malware. Yeah, and so on and so forth. Try to get a good idea what's in there. Yeah? And you can raise the bar, but use tooling to get visibility. But my advice is try to figure out what these tools check for, because hackers, they know how to evade them. Yeah? That's why I'm saying put an entire infrastructure in place with multiple lines of defense, not rely on 3V, only. So then I come to my favorite part, CI/CD. Nobody thinks about it, but CI/CD is basically a very useful scripting tool. It uses YAML typically, and everyone has his own YAML code. The moral of the story is there are no scanners to scan your CI/CD pipelines. And if you think what you do in your CI/CD pipelines, you don't have to answer me, but it's a nice playground to do everything you should not do with Docker. Yeah? Like mounting Docker Hub or credentials. So please treat them as code, check them, get them analyzed, because I said this is not against, this is true for Azure DevOps or whatever. This is a GitLab, because I had a GitLab which was hacked. I can override system variables in GitLab. I can change your job ID. I can inject code. And I didn't find personally a way to stop it. Yeah? That's perhaps me, but these CI/CD systems, they can trigger webhooks. They have credentials. So this was something I tried to do, to basically inject code into the next pipeline. It works. Yeah. I went back to my friend Tekton, and this is not a problem of Tekton. This is just because how these containers underneath are being built, and that's your responsibility. I could inject backdoors. I could do command injection. I can do even command injection through a curl, and nothing stops it. If your CI/CD system is triggered to a web API hook coming from I don't know where, is GitHub doing it to you? Maybe I can, because you need to have something in place that blocks all the rest. So check it, because it's very, very, very dangerous. The next night, I was totally bored, so I tried exploiting startup probes, injecting code. It goes undetected. I used the HTTP GET ones. The cool thing is you can do SQL injection, you can do bash shell or shell shock. Nothing stops it. I reported it, and they said it's not a bug. It's as designed. Okay. Fine. But a network policy in Kubernetes cannot spot this issue. You can prove me wrong, but you cannot do that. And I'll tell you another story. These probes are executed by kubelet. Kubelet is something that runs on a Kubernetes cluster with full root as a process that bypasses network policies. Kubelet is not stopped by network policies, which is the ideal place to do identity spoofing, all right? So be careful with this, because if you copy-paste my examples, it will run. So I tried with shell shock. Again, I couldn't find anything else than a real enterprise-graded IPS feature to basically tell me, hey guys, something in that Kubernetes cluster is doing shell shock. And the problem is, it's very hard to stop, because it's a pod. And as you know, typically everything is source netted on the Kubernetes clusters. It's pretty hard to stop a node from sending traffic. Yeah? So there are solutions. Feel free to look at these red t-shirts. You can do the same. Who knows about pod lifecycle management? It's a very strange thing, very weirdly documented. But again, you can inject backdoors. These backdoors, I repeat it, they are not in your source code. They are not in the containers images. They are in the Kubernetes YAML file. Yeah? So it's pretty late in the phase while you create your artifacts. So please, if you check me out on LinkedIn, you've seen I've worked for runtime companies, but there's really a good reason to have Kubernetes runtime. Whether this is in Kubernetes or this is in front of your Kubernetes cluster, I don't really, I'm not opinionated here, but please do these things, like security admission. How many people know that you should not run a privileged pod? You probably know that you cannot do that. You know, you can take over an entire cluster if you can run the privileged pod And what is going to stop you from running a privileged pod? Even if you only have access to one namespace, you can still run a privileged pod. And you can take over the cluster. If you want a demo, I can show you one. Use network policies. I know they're complicated, but it's a very good thing to isolate things. Check out the role-based access control in Kubernetes. That's another very long talk. Turn on auditing, container scanning. Use these gatekeeper functionality. They can help you quite a lot. And try to detect drift and enforce immutability. Yeah, so that nothing can change in production. It's a pretty good open source tool. I don't know if you know Robusta, but it actually, without me knowing it, it captured a very weird attack, while stuff that was running in Kubernetes was basically changing, as you can see, from one repo to another. Which means that that Kubernetes cluster decides on its own to basically go and check out another repo. Maybe it's just me, but I would love to know that up front. There are cool tools. I think it's somewhere based here, Cilium. They have something called Tetragon. Check it out, it's a new project. It can basically detect a lot of nifty stuff in your Kubernetes cluster using eBPF. Certainly worthwhile to take a look. Other things which are perhaps a little bit more known, Falco and Sysdig. The problem with these tools is they are very hard to use. I personally like Tetragon because it's YAML-based and then so on and so forth. But let's say this is more advanced. I'm not opinionated here. But check these things out. At least these open source tools are not going to block you, but at least you get a bunch of alerts. Yeah. And last but not least, if you get bored one night, check out role-based access control in Kubernetes. And run security tools in your Kubernetes clusters. And check out these privileges. I don't know if you can see this one, but this means that you have full access in your Kubernetes cluster. Yeah? So be very careful. There's a pretty cool tool. It's called IMO Sec. You can use it as an open source. And it has, I'm not going to say a good, but it has a role-based access control viewer. And you can query it to see, can I do this and who can do that? And just by looking at the screen, you probably get called. So check out these things. And these are stuff that you cannot do while developing. Yeah, this is in production. Yeah. Any questions? Feel free to ask me now or after, but I think somebody is looking. If you go here, you can download the slides and all the stuff. Reach out to my colleagues. Both are here. They're specialists at Fortinet in public cloud. They know all the stuff. I'll thank you.